fellow. We'll wait for a few more minutes. Anyways, see Michael gets back and get it working. Hope he didn't go out to go buy a new computer. I don't know if that's the fellow Gister. Is that you, Michael? Probably not.
Is that better?
Yeah, still better.
Not sure what the problem is. I have a new computer and it's got all the bells and whistles, but it won't talk to Jitsi for some reason.
Oh,
wasn't able to figure that out. I tried earlier, but I couldn't connect to it. So I'm okay now. I'm on the old computer now.
Okay. Well, maybe someday we'd try it out another day.
Yeah. Okay. Good. I'll set it up with you, Peter, and try it out. Okay. I'm here.
Okay, I'm not sure. Yeah, and I think Ken said he might have been going away. I think he's away on vacation somewhere. I'm not sure though. So I guess we might as well. Are you ready to go there, Michael?
Yeah, I'm just starting up PowerPoint here.
Okay. Well, while you get started there, and I'll just do the usual. Welcome everybody to our homebrew mixer meeting for January 2024. Hope everybody had a good New Year's and Christmas. It was very quiet for us, which I'm starting to like these days. Oh, please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. And by participating in the meeting, it is understood that you have accepted the terms. So tonight we're going to have Michael talking about his experiences with his spectrum analyzer, and I guess maybe some helpful tips there as well. I did have on the agenda for a topic of interest, but we're going to defer that one. Howard's has had some questions and then some experience of late of doing some LT Spice simulations of his low pass filters, etc., in his T41 transceiver build that he's doing. I think it started off by a part was missing. So what should he put in, or what could he substitute in, and see how it's performing. So I think Howard's got a couple of screenshots or a few questions, and I saw one of them would look pretty weird, pretty cool. It depends on what way you look at things. And so we'll talk about that instead and see how that goes. And then whatever time we have left, then we'll have our usual roundtable. Okay. Did I blabber enough there, Michael, or do I still have to chat?
Oh, I'm ready to go. I'm ready to go. I'm good to go.
All right. Where you go then?
I'll share my screen.
Yep.
There it is. And now, okay.
Well, if you're sharing.
Okay, now let's see.
Okay, there you go.
Okay, now. Can you guys see that?
Yep.
Okay, good. We're good to go. All right. So anyway, I'm gonna talk about some basics as I understand it with a spectrum analyzer. So feel free to criticize or heckle or whatever. Okay. So I have the Signant SSA 3021X, which I sort of figured out how to use, and I did a presentation to the Mississauga Club before Christmas, and this is it here again. So I start with the basics. What is a spectrum analyzer? It's a test instrument that displays the frequency components of a signal, and it shows the magnitude on the vertical of the signal, particular frequency component on the vertical axis, and the frequencies themselves on the horizontal axis across the screen.
Hey, Michael, your slide didn't change.
Oh, it didn't?
No. We're still on the opening.
Oh, wait a minute. That's weird. Hang on a minute. All right. Wait, that's no good. Hang on a minute. What's going on here? It works here. Why doesn't it work there?
We've come across that issue before. I think Dave had that issue at one time, but I can't remember now.
Yeah, I can figure. If I can just get it started, I can figure it out here. What's going on here? Okay, I got to put it in slideshow. Okay, do you see that slide?
You're not sharing the screen any longer.
Okay. Yeah, right. Just a sec. Where is it? There it is. Okay, there's the shared screen. And here's the window. And where did it go? It's there. Window. It's there. Oh, just a second, guys. Hang on a minute.
Call from 905.
All right, let me try this again. Start screen sharing. Just a second. Go back to the beginning. Now we'll minimize this. Okay. Here we go. Window. Entire screen. Sorry guys, hang on. Cancel. PowerPoint. It's there. Share screen. Now, can I go through that? Yes, I can go through that now.
Can you see your presentation in the share window?
Okay. I'm just doing that now. Okay, there it is. Okay. Share. So you can see that, I guess.
Yes. We see the opening screen for all your other screens on the side, or slides on the side.
Yeah, that's right. Now, do you see the second screen?
No.
All right, never mind. I'm just going to go back the other way. Never mind the other one. I don't know what's going on. Okay. So, yeah. So you can see the second one, right?
Now we can see the second one, yes.
Okay, yeah. So anyway, the spectrum analyzer displays frequency, magnitude, and on the vertical axis, and the components, the particular frequency in the horizontal axis. So it gives you all the components of the frequency of the signal. In contrast to an oscilloscope, which is only the signal versus time, whatever that signal is. And the spectrum analyzer displays a much better dynamic range in that, if you look at an oscilloscope and you try to look at the particular frequencies, it's awkward. So you can see things much better on the spectrum analyzer, what I'm trying to say. So some of the basics. I plagiarized blatantly from other stuff. On the left-hand side here, this is the time. This is what you see with an oscilloscope. The time domain signal of all these added together at various different magnitudes. All these different frequencies added together at different magnitudes. If you look at it from the frequency spectrum, the frequency domain, this is what you see: the magnitudes of the individual components. These guys here. And in the time domain with an oscilloscope, you can't see that, but you can with the spectrum analyzer, and that's the basic difference. So in the time domain, you can see the changes in time. It's difficult to pick out the individual frequencies, whereas in the frequency domain, you can look at each element individually, so you can see them. You can look at spurious stuff, and you can look at low-level signals as well, much more easily. And the modulation I'm not going to go into because I don't know much about it. Let's go down. Oh, yeah, okay. So, oops, sorry. Yeah. So the spectrum analyzer looks at it basically does a Fourier transform, which is a mathematical function. This is it here. It's Laplace transform of the frequency function. The omega here is 2 pi times the frequency. That's how the frequency gets into this formula. So it basically integrates this stuff and gives you the frequency domain stuff. Like at the bottom here, here's a time domain signal. It's actually a whole bunch of fundamental harmonics that create the square wave, more or less here. And when you look at, that is for a square, but when you look at in the frequency domain, you see the fundamental, the third harmonic, the fifth harmonic, and so on, all displayed across the screen. So when you look at different signals, this is what you see. For a sine wave, you just see there's the sine wave looked at from an oscilloscope point of view. You just see the one signal of the particular magnitude. For an AM signal, you see the carrier in the middle and the upper and lower sideband here. For some kind of noise signal, it's limited by a bandpass filter. You see this kind of thing in the frequency domain, and a PSK signal is different again. So this is the spectrum analyzers. A few of us have this. It's got the various functions here. Down the side here, in number 2, you can select different things. This marker is over here someplace. This is a keypad. It's even got an audio output too, and a connection for a USB key. Change the dial. You can change stuff on the dial. This is the RF input to the signal generator, to the spectrum analyzer, and this is the tracking generator output, which is built into this particular one. So this diagram came from Al Woke, W2AEW, and starting at the input here, this is the frequency range you've set up your analyzer to look at, and there's a particular frequency, input frequency. Let's say it's just one frequency. So that's the RF input. There's an attenuator here to protect the rest of the circuitry. There's an oscillator here, local oscillator, that's driven by a ramp generator, which means the frequency that the oscillator puts out increases linearly, so it sweeps across the frequency range. So the oscillator also sweeps across its bandwidth. That goes into a mixer as well as the input. So you get an intermediate frequency, which is the usual sum and the difference of the frequencies, the input and the oscillator frequency. And that's passed into one of several resolution bandwidth filters. These are nothing more than bandpass filters of different widths. So if you look at, depending on which one you use, you get better resolution or not. So narrow resolution bandwidth means a narrow frequency range that these things are passing to the output of the filter, and that is detected nothing more than some kind of AM detector. And then you have a choice. You can either feed that signal directly into the Y input of the analyzer, the vertical input, or you can pass that through a video filter, which is basically a noise filter. It cleans up the circuitry, cleans up the signal, and you get much less noise in it. So that's how you get your vertical input to the spectrum analyzer, the RF input. And the ramp generator signal goes into the x-axis, the horizontal axis on the analyzer, so that means it sweeps across. It sweeps across the screen. It also has a tracking generator, and the output is on the spectrum analyzer as a terminal, so you can connect that to a filter, for example. So what it does, it allows you to measure filter characteristics and amplifier character gains and whatnot. And it basically, the tracking generator output frequency coming out of it is exactly the same as the frequency that's being swept by the analyzer itself. You apply the output to the tracking generator to one side of your filter, let's say, device under test, and the other side you connect to your spectrum analyzer radio RF input. So the tracking generator sweeps the input frequency, and the spectrum analyzer displays what it's seeing coming out of that filter or that amplifier. So that's what it does, more or less. So this is an example of a 40-meter filter. It's the LBS 40-meter filter. And down the left-hand side is the magnitude of the signal. And across the bottom here is the frequency, and this is a standard frequency characteristic. You can set it up to, there's a number of different markers. There's actually 4 markers. I'm only using one here. And down below here, it tells you the attenuation at the point of the marker, minus 1.45 dB, and the frequency is 7.10. That's also displayed up here on the screen. There's a 20 dB internal attenuator in here. The reference is minus 5, so 5 dB per unit coming down here. And you can set the center frequency, which is not displayed right here, but it's over here. The center frequency is 7.2. The span is 4 megahertz from one side to the other across here. And what else? The resolution bandpass filter, RBW is 300 hertz. Come back to that later. And there's the video bandwidth filter is 3 kilohertz. And this allows you to set the 3 dB points. So you can look at 3 dB points, which is what these are, here and here. You can also put markers there and see what it tells you here, what the bandwidth is. It's 373 kilohertz at minus 3 dB. So there's a lot of information you can look at here. You have to be really careful with these things. You got to be really careful to not exceed the maximum input levels, which in this one is 30 dBm, which is 1 watt, and the maximum DC input is 50 volts. You got to be careful about harmonics. You got to remember that a square wave, for example, has a whole bunch of harmonics, all of which get added into the spectrum analyzer, and have to be really careful because you destroy the inputs. As some of us know, very bad news for the owner of the spectrum analyzer. And the best practice is to keep it below 50%, so no more than 15 dBm and no more than 25 volts. And you should always use attenuators to be safe, just until you know what you're dealing with. So yeah, dBm versus milliwatts. I just added this in here. dB is 10 times the log of the power ratios, for example. So if it's in terms of dBm, you put 1 milliwatt in, and you get however many dBm out. So for example, a 13 milliwatt signal gives you 11 dBm. And you can take that value and you can convert it back to power. So if you're looking at a signal, square wave output, let's say across the spectrum analyzer, you can look at the peaks, the peak dBm levels, and you can calculate backwards to find out what the power is. But you have to take each dBm value in turn, convert it to power, add all the powers up, and then convert the resulting sum back to dBm to get what the real dBm signal is. Hope that's clear. So when you set it up, you can set up the center frequency and the span, or you can set a start and stop frequency. You set the reference level, you set this resolution bandwidth figure, and you set the video bandwidth as well. So this is an example of a 7.1 megahertz sine wave. The value is minus 35 dBm at 7.1. And the resolution bandwidth here is 3 kilohertz, and the video bandwidth is also 3. So this is a square wave. and you can see the individual components, the fundamental, the first, the third, the fundamental, the third harmonic, the fifth harmonic, and so on. And with the marker table, you can get the individual values. And if you wanted, like I said, if you wanted to calculate the power output of this square wave, you'd have to take these dBn values, convert them individually to watts or milliwatts, add up the milliwatts, and then go back to calculate the dBm. You can do it though. Over here, the center frequency, the start, the stop. I don't know what this frequency step is, but I haven't figured that out yet. But anyway, you can sort of see what you got. Up here is the fundamental, or where the marker is, the dBm for the marker. And over here, I'm using automatically 20 dB internal attenuation. This is an AM signal, and the center frequencies here, the upper and lower sidebands are here, so you can look at this stuff. And this is FM, again, the fundamental, and the other harmonics here, other frequencies rather. So when you look at the bandwidth RBW, if it's too wide, like too large a bandwidth, you really don't see what your signal is. And the left hand, you can see this here, the left hand one, this is not so good. You really can't tell what that signal is. You change it a bit and it gets better. You narrow it a bit and you change it even more and it gets even better. And so this is the same thing put another way. This is two sine wave signals separated by 20 kilohertz. This is the greenish gray color. If you look at it with 30 kilohertz resolution bandwidth, you can't see anything. You can't tell what that is. When you reduce it to 10, like cut it in by a factor of 3, then you can sort of see a bit of a shape here, but it's still not really what you're looking at. When you go down to 3 kilohertz, you get the individual peaks, so you can tell where you are here. And one of the consequences of the narrower bandwidth is that it sweeps a lot slower, and normally you can't see a sweep going from this side to this side. It's faster than you can see. But once you start getting down to the, not so much here, but if you get lower than this, and these things can go down to, what is it online? It goes down, I can't see it, it's not turned on, but it can get pretty like 10 hertz or something.
Hertz,
in which case, big friend?
It's 3 hertz.
What was that?
Hertz, 1 or 3 hertz, I can't remember which. It gets pretty slow.
Yeah, 1 or 3 or 10 or something. It's very, very good anyway. But when you do that, the signal just creeps across. Like you can see it. You can see the sweep happening just sort of like this. You know, it takes forever. So the consequence of narrowing the bandwidth is a much slower sweep. So that's the RBW. The other one, which you can turn on or off, is the video bandwidth. And what that does is it removes the noise level. It lowers the noise level significantly. And this is for an FM signal. You can see on the left, there's a fair bit of noise here. But when you put the RBW on to 3 hertz, I think that I can't see. Anyway, you put it on, and almost all the noise goes away. So it cleans up the display a lot. So anyway, that's that. And just a bit of, I think I talked about the Tiny SA before, just a couple of slides here. This is the Tiny SA, which is the $60 version of your $2,200 spectrum analyzer. The original Tiny SA had a 2.8-inch screen across corner to corner. The Ultra has 4 inches, which is the same size as the Nano VNA. It's got an internal battery. There's 2 different inputs you can put in, and the maximum is 10 dBm rather than 30 for the Siglant one. You can use it as a signal generator, all kinds of stuff. Anyway, don't want to go into too much. This is what it looks like in the box. Comes with an antenna, comes with a couple of cables, and a female to female SMA connector. And like I talked about the interface, and that's really all I had to say. This is it in use with the AM signal. So you can see it's not nearly as good. This is a 3.2 kilohertz bandwidth RBW filter. It's not nearly as good as the Siglant. Anyway, that's all I had to say. And these are the references. Al Wilkie, IMSAI guy's done some stuff, Rode and Schwartz and whatnot. So anyway, that's what I have to say. Any questions? Hopefully not.
I mean, hopefully not. I
I'm
like your
going to go back to the.
Yeah,
I'm going to go back to the.
That was an interesting perspective it was showing in slide 19, the sine wave separation. That was another good depiction of it. Have you tried to network your spectrum analyzer and scope?
I've got as far as using the USB connection to the laptop, and it works fine. And you can adjust it. You can control the spectrum analyzer remotely with that from the laptop. Mm-hmm. The difference is that there's some quirks about it because you have to go back to the main spectrum analyzer to make some changes and then come back. I forget the details, but I have done it. It does work, and it's pretty effective actually. So that'd be a good way to show somebody's stuff.
Yeah, I do that as well, but I don't make the changes I basically don't do much changing on the software. I go back, I just disable it and go back in the spectrum analyzer, make whatever changes I need to make, and then reestablish it. But I was talking about from the LAN network. I tried one day to network.
No, I haven't.
Yeah, it wasn't too successful in doing it, but I never got around to going back to it again.
I haven't actually tried it. I know you can do it. I just haven't done it.
Yeah, I think it'd be a great idea if I could, but anyway, for another day, I guess. And I have not played around with the video bandwidth settings at all. Have you done much on that? I see you on your screen there. It cleaned up the noise. Is that clean up the noise that's been generated inside the spectrum analyzer, or is it just clarifying noise?
I don't know. Let me see. What was I doing? I was looking at. I was using the Siglant SO, the 1032X to create the signals for that.
Mm-hmm.
So that I presume is pretty clean, but I don't know. I presume so. I would assume it's maybe the internal noise. I just don't know. I haven't looked into that.
Okay.
So it's pretty dramatic how it cleans it up.
Okay, thanks, Michael. Very good. Got a couple questions else here for you. Howard, you're up first.
When you use an oscilloscope in FFT and it gives you the options for the different algorithms, does a spectrum analyzer have a proprietary algorithm? Like if you buy a Signet, it has one, or does it still give you the options for the different styles?
I have never looked into that. I don't know. I know what you mean about the FFT function in the scope. I would have to look. I don't know. I haven't got that far into it.
I don't recall seeing the different settings like that on your spectrum analyzer that you see in your scope. I mean, Dave might have some insight on there, but we'll get them in a minute there. So, any other questions there?
It might be in the.
Sorry, go ahead, Michael.
It might be in the menu somewhere. I don't know. I haven't looked. One of the sub menus, perhaps. I printed out the manual, a 100-page manual or something, but I haven't looked at it, so I don't know.
Do you have another question there, Howard?
Nope, that's good. Thanks.
Okay, Dave. Good evening.
Yeah, hey, Howard. I think you're referring to like Blackman or Harris, or those are.
That's
is
right.
that correct?
Yeah. Yeah,
hanging and all that. That's a windowing function. It's not has nothing to do with the FFT. What that has to do is if your spectrum analyzer is continuous, okay, the scope is taking buffers, it captures a buffer, it captures a buffer, it captures a buffer, it captures a buffer, and each buffer it does an FFT on. Okay, it's doing an FFT on each buffer. It's not doing an FFT continuously. So each time you take a buffer and you do an FFT, and the next buffer you do an FFT, the start and the end of the last buffer may not line up. And if you do an FFT, it may generate all kinds of spurious spurious content. So what you do a window over that buffer, and you kind of cut off the endpoints.
Oh,
You take it to zero, so that when you do the next buffer, you get a cleaner transition. That's your windowing. That's a windowing function.
oh, okay. I thought it
Okay.
was a different algorithm.
No,
Oh, okay.
no, it
So
has
that
to.
makes sense why it's
It
not in
has
a.
to do. Yeah, it has to do because you're grabbing buffers and you're doing an FFT on a buffer, and the next buffer it does it on is not. It may not be like the buffer may end at sample 100.
Right.
It may not start at a address of 101. It may start at 105, and so all of a sudden you can have your wave coming down and it jumps to some other value, and that in FFT space represents all kinds of nasty frequencies, right? So that's all of a sudden going to show up in your scope. So what it does help you clean up noise, okay? But it's not noise in the signal. It's noise from the FFT,
From the
if that
display.
makes sense.
Oh, okay. Thanks. I didn't know that.
Yeah. Okay. So, and I was going to say something. Oh, video bandwidth. That purely has to do with the screen. It's how it's going to resolve the signal on the screen. So it's not the signal in the background. It's just making it easier for you to see. So if you increase your video bandwidth, you're only doing that on what's displayed on the screen. The data, it hasn't touched it. It's just what you're seeing on the screen. Does that make sense? Hence video.
Yeah,
That's why it's called video.
Yeah, that makes sense. Okay.
Yeah, the reason why I brought it up
Yeah.
there, when you're reducing the say the noise, it's like on the noise floor level there. I'm thinking, oh, geez, yeah, but if that's an actual thing, I don't, and you can adjust it out of there, you might not think it's there when it really is, but that's not what you're yeah.
The best way to on your scope anything to address noise is to do like it's called a low pass filter. You're trying to get rid of all the noise, and the way you do that on your spectrum analyzer on your scope, it's called averaging. Okay, on your on your signalant, if you go into sweep, I think it's sweep or trace. If you go into the button that says sweep or trace, one of those, I think it's probably trace, the button that says trace. If you go in there, on the side, you'll see something says AVG or average, and it's set to, I think, 0. So what I do, normally I'll run that sometimes at 100. So it's taking 100 FFT points, sample, averaging it, and then plotting it. So any kind of fast noise it's got in there in that 100 samples, it's smoothed it out. You get a nice smooth. So if you've got your spectrum, it's got all kinds of gnarly crap, you just go to 100 and all of a sudden you get a nice smooth spectrum coming out. Same thing on your scope. On your scope, you've got an average. If you go to on the signal, if you go to acquire, there is I have to look at the buttons. There's an acquire button. If you go to acquire, there'll be on the first button, I can't remember, it's got like peak. It's got a whole bunch of things for how it acquires the data. It looks for peak values. And if you keep coming down, there's an average. And if you use your little rotary dial, you got a little rotary cursor dial. Do you guys know what I'm talking about, right?
Yeah.
Just a little, you can adjust your samples with that. You could turn it, and I sometimes run that on my scope. I rarely go beyond 32. It's usually 4 or 16 I run my samples at. And if you've got a gnarly, if it's a really weak signal you're bringing in, it'll smooth it out, and you can capture it, and it looks really nice. There's a guy who did a video on that a little while ago. Did I not post that on the channel, where he talks about detecting weak signals in a scope by doing averaging? So
I don't
anyway,
remember.
You did, Dave. I don't remember it. Maybe repost it again. The link.
yeah, okay. Anyway, I was going to ask a question, and geez, I got off topic. Jeez. Oh yeah, I remember. Michael, did you ever apply that patch to your scope, to your spectrum analyzer to unlock it? I know Peter did.
What patch is that? I didn't know about that. I don't think I did.
There's the original hacking into your spectrum analyzer was a huge deal. You know, you're getting right into the firmware and all kinds of things, and you had to be very careful. You would brick it. But relatively recently, there was a, how do you word it? Oh, you pick up this script. It was a Python script that's out there, and you would put in your serial number of your spectrum analyzer into it, and then it would generate all the licenses that you would need. So you would go to your spectrum analyzer and put in those licenses, and that would unlock it. It would unlock all the extra math routines that's available to you, as well as bump up the maximum range to, was it 3.1 or something like that, or 4? I can't remember which. So it's a much cleaner and easier way, and no risk of locking up your spectrum analyzer. Because if you push the wrong button on the license, it just says wrong license number. Start over.
So does this get you the? I know the spectrum analyzer has a number of other options. Is that what you're talking about being able to get doing that?
Yes.
Yeah, it's
okay.
It's like it.
I didn't. I'll have to go find that.
I'll see if I can
it
find
could
it.
do.
Say again?
I'm not too sure whether I posted it or anyway. I'll see if I can dig it up. I can't remember where I would have put it, but I'll see what I can find.
Yeah, the unlock, Michael, allows you to do SWR measurements. You could do some advanced math calculations. You know, there are.
Okay.
I think
Stuff and
there was a couple of times I wished I had the advanced math features, but so far, you know what? I've never used it.
Mm-hmm.
but when you want it,
It had to do with modulation. Because it could it can, I think it was, could it demodulate certain things? It had to do with a modulated signal. It could come back and give you some information about a modulated signal.
That's something worth looking. I'll look into it. If Peter can find the link, I'll have a look at it.
we can dig up.
You got to be careful
Peter
with these
did-
things. You don't want to mess it.
That's right. Well, as long as you've got your original license, you record it, take a picture of it, you've got your original license, there's no danger, you just put it back in, right?
That's right.
Mm-hmm.
Right. So, but Peter, have you verified that all those features work?
Yep.
Now, since you put in that license, did you find that your spectrum analyzer was, because I remember you said your spectrum analyzer is off by about 2 or 3 dB.
That was way before.
So that didn't have anything to do with it.
No, mine's been reading low for a long time, way before I ever did the hack.
Okay.
Yeah. So what it did have me wonder though is, you know, with all these fancy math functions, you start doing that, and then I'm reading low. So, anyways, I stopped thinking about it because it was keeping me up at night. Anyway, any other questions for Michael? Very good. Okay, thanks for that, Michael. It's a good way to learn how to use your instruments is to do a presentation on it.
Yes, it is. Yeah, that's right.
Okay, and
I know a lot more. I know a lot more now than I did before. I put it that way.
Howard, are you ready to have a little chat about your T41 filters?
Yeah, I can do that now. Do I need permission to share the screen or?
Oh, you should just be able to go right ahead. Yeah, here's another of have a problem, and then you'll learn how to use your equipment.
All right, but just give me a second here. I don't know why this happens.
Yeah, the easiest thing I find to do with the screen sharing is if you go into start sharing, screen sharing, do not try and share a window. There's a tab that says entire screen. Click on that and share. It'll share your entire screen. Once you start trying to share a specific window, like your browser window, that's when you start running into problems. Okay, just share your entire. There you go.
There, can you see that?
Yeah.
So you can see the LT splice display?
Yes.
Oh, okay. So, like Peter said, I was putting together one of the filter boards for the STR transceiver, and I realized I was missing a capacitor. So that led to a discussion about substituting capacitors. So Peter helped me set this up, and when ran the filter that's on the top right here, you see the graph on the top left where it had that notch, and you see the phase changes. But then when that capacitor, it's C201, when that capacitor was removed, you saw the graph on the bottom right. So what I didn't understand is why that capacitor was causing the display. You see that notch, those two notches versus the straight slope.
You built a crystal.
Yeah.
That's what
That's
Peter
a
said.
crystal. You've got a series and a parallel resonance.
It's what?
You've got a series resonance. You've got a series, an LC series resonant, and an LC parallel resonance. That's what those two peaks are for. You've got two resonances, right? It's like a crystal. That's what a crystal does.
Okay.
Except I think it might be the other way around. I don't know. But Ken's got his hand up. He may have more insight.
So
Yeah, that capacitor, basically what you're doing is you're linking energy from the first part of the filter to the next part of the filter. When that capacitor is very large, and that is very large, then you start introducing ripple and everything into the passband. So what you could do is try smaller capacitors, like 5, 6, 10, but I wouldn't go any higher. And that applies to pretty much all filters.
Just to clarify with Howard, that C201 in the original design for the T41 transceiver, it does specify a 56 picofarad capacitor there, correct?
that's right. And then it was the same for the 80 meter that's in the left middle schematic. It also had that same parallel series setup, but the other bands didn't.
Just try some smaller caps.
Yeah, it's to me, it's interesting that their design shows that. Why would they have that, in their final design and leave it in like that? I mean, I know that's a work in progress, but it seems like, like Ken suggests, go to a smaller value and see what happens.
Well, what is it?
Well, that plot at the bottom, the second plot at the bottom, it looks like a Chevy filter where you've got ripple in the stop band. So it looks as if it's coming down, and and then it's coming back up. And if you were to probably sweep it further, you may see other notches. And that filter may be just a Chevy Type 2 filter, which has got ripple in the stop band. Because if you look at the stop band, how down is it? Minus 80, minus 50? I can't read the scale.
Which
What's the
which
scale
one?
there, Howard?
You
On
talking
the
about the
bottom?
left-hand one at the bottom or the right? Which one are you talking about? The left or the right at the bottom?
Left-hand one at the bottom.
Oh yeah, okay.
See how it's got the dip? See how it's got the dip? Geez, I can't read this.
Yeah, it's up at 16 megahertz, around 90 dB.
Yeah.
90 dB.
At 16 megahertz, that's probably your stop band. Okay, so that filter is probably like a Chevy filter. And what a Chevy filter does, it's got a stop band. It's got a point where it stops, and then you get ripple after that frequency. And so you see how it comes back up after that 16 megahertz? What I'm suggesting is if you were to sweep this, not to 30 megahertz, but to 300 megahertz, you may see a whole bunch of those dips. And if you're seeing a whole bunch of those dips, this is a Chevy filter, Type 2 filter.
But in the case of this bottom left-hand filter, there's really nothing wrong with that sweep. But if you go back to the original
That's right.
sweep on the upper left, the upper left one, there is
but I'm just saying the bottom one. If you look at that, that's what, minus 90 dB down.
Yes.
What's the? I can't read it. Is
Yeah,
it minus 90?
Yes.
Mhm.
Holy, that's a lot of attenuation. That's pretty damn good, because if you look at the stop band, when it comes back up, the stop band is like minus 70 or 80
72.
dB down. Holy shit, that's pretty good. You're getting 70 dB of attenuation past your stop band. So I think the thing is, you got to go back to look at how this filter was designed, and they're filter designers. I'm sure this is you go to a Chevy filter designer. Doesn't what's that program that does filter
LC.
designs?
Elsie, yeah, Elsie.
Yeah, doesn't else do that? Couldn't you go in there and plug in values and say what filter you want? Go in there and say, I want Howard. What are you trying to? You're trying to get, what band are you trying to get it to stop at?
Well, no, it was just to find a substitution for a missing capacitor. That to see the impact of changing that value for the capacitor value that I had, which wasn't the one that was in the design.
Yeah.
So that's what started all this. So I don't really know why they designed the filters this way. Maybe it had to do with the digital filtering that's the component. I'm not sure.
What would be interesting, Howard, would be to take it, because I know you don't have a spectrum analyzer, but or do you? No, you don't, right? So,
Well, no, but I did that. Let's see if I can find that picture. I put it on the Nano VNA.
And did it show that peak and dip as well?
Can you see that?
Yes.
Yep.
So that's what it looks like on the Nano VNA with a 50 ohm load.
That's the filter on your upper left?
Bottom right. That's the 10 meter one. That's the only real one I have. Yeah, no, I don't have the 80 meter one.
No, the upper left is 40, isn't it?
Or 40, yeah. So no, this is the same as the bottom right.
Which is okay.
Yeah, it's too bad that's the only real one I have.
Wait a minute. You're one on the right's not a 10 meter. It's 10 megahertz filter.
Or sorry.
Yeah, 30 meters.
Sorry, yeah.
Hassan, I think, has a question for you, or a statement.
Question this and statement. Question was, which capacitor was it that you added and it caused that those distorted waveforms or those distorted frequency plots?
The 201. Can you still see it?
No.
Oh, what happened here?
Well, I think there's a confusion here. I'll just clarify, if I may, Howard. Howard had a missing the upper right hand schematic is what the T41 shows for its filtering, and then Howard had the C102 or 201, whatever it was, missing. So the question was, what could I substitute in there that I have in my junk box? And this is what started it all. But when you put in the capacitor that was called for in LT Spice, it shows that, well, like that crystal like hump at the end of the filter there, or the display.
What's a T41?
Oh, it's a transceiver that was designed a couple of years ago by, I forget the guy's name now.
Okay, so C201, when you subbed in a different value and you got a really distorted plot.
No,
It's
when the original one calls for 51p.
right.
And that's the display you're getting. I'm just saying that's odd that you design a filter that would show that kind of display at the upper left.
So what's this dotted and the solid line again?
The dotted is phase, I think.
Yes.
And
Yeah,
solid
the
is
dotted phase.
magnitude.
Oh, okay. Yeah, so this is all I can think of doing is if you take your circuit, pick a frequency, and just plot the impedances for each component, maybe that'll give you more insight into what's going on. So like for each capacitor and inductor, replace it with the impedance at a certain frequency, and see what you'll probably see a pattern right away. One of these values is going to be like 10x out of whack or something, and that might give some more insight.
One thing I was wondering is if it's just the way the components were in LT Spice. Even I was going to say, Howard, maybe one thing you could check. I know it's going to be a bit tedious, but put a signal in on your scope and then just go sweep it manually and just make note of the different values of the different frequencies and see if that funny little curve bit there, like the crystal curve thing, we'll call it, shows up on, confirmed by your scope in the real world, just to say, yeah, Spice is showing you what's going on in the real world.
Yeah, I'll have to wait to build that 41 to see that, the 40 meter one.
Oh, okay. Yeah.
Yeah, that makes sense.
Well, you could do with any of them to confirm Spice is showing you what's in the real world.
Well, the bottom right did look like the BNA. That's the only one I have in real life.
So it looks like the resonances are off by a little bit. So if you see the top left image, the second hump on the right, if you move it to the left so it overlaps the dip, then you're going to have a nice flat thing with a little peak and then a nice sharp roll off. So maybe that's the problem, that the LC resonances here are not lining up the way they should.
So C201 could be causing that crystals display.
Yeah, possibly. I mean, if you change the value slightly, that peak will sweep leftwards, hopefully.
Did you try that, Howard? Lowering the value of C201 and run it on the Spice?
Yeah, okay.
And what did it do? Or you haven't run it?
Well, actually, now that you mentioned, I think it did do that. Yeah, I think it did shift it, but the two peaks were still there. But
So, would you have expected if like the upper left graph, if it had been, let's call it ideal, what it should have done, it should have been that same slope all the way across. Is that what you think? Is that what you're thinking?
well,
It should look like the lower right.
Yeah,
It should look like the lower right, in which case it's flat until
Yeah.
some particular frequency, and then it rolls off. This one is sort of rolling off right from the left to right to start with, but it's got
That's a funny looking LPF, isn't it?
Yeah. Well, the bottom one,
I think
right, looks like a low pass filter, doesn't it?
yeah, but
I think
but it doesn't have that parallel.
Yeah, I understand. Yeah, yeah, sure.
One thing to
I
also
think
check
Ken
is
is right. You've just got ripple. In that first top left curve, you're just starting to get ripple. That's what that peak is, right? And that's coming from some kind of resonance with that capacitor and probably one of the there. So I think you get, like, it's a Chevy usually has ripple in the stop band, like that bottom peak, the first peak. It'll come up, then it'll oscillate up and down, but it never goes back up to a positive peak as high there. So you've got too much ripple in band. If you look the bottom filter, that's a much more well-behaved filter, right? And the filter on the right, bottom right, that looks more like a Butterworth type filter
Yeah.
where it just slowly comes down, right? And that's probably from that traditional like LC, like the pie filter. That's probably coming from that pie. Once you start adding that capacitor in, you're changing the characteristics of it. Now, why LT Spice is doing that? I don't know. The other thing, Howard, this might be a boondoggle, okay, but sometimes LT Spice leads me astray. And what I'll do, instead of doing a Bodie plot, is what I'll do, I will, on that AC source, I will change it to a transient. I will change that to a transient analysis and feed in frequencies in the pass band and feed in a frequency in the stop band and see how much it's gone down.
Okay.
And just see if that matches what the Bodie plot is telling you. Like, for example, okay, if you look at that top left-hand plot, okay, the one with the peak, okay,
Right.
the top and one, the one with the peak, determine the frequency of that point, right? And do a transient trace at that point, and take a transient trace at, say, somewhere down really low frequency in the where it's smooth in the pass band, and compare to see if you're actually seeing a peak.
Okay. Yeah, because I didn't expect it to look like that. Expected it to more look like the bottom right one.
Yeah, because I've found LT Spice can lead you down the garden path. You just got to be careful with it, and just trust but verify your results.
All right.
Right. Good advice. Wayne, you got a comment? Question? Nope. Wayne, you got a comment or a question there? Huh. Can anybody hear me?
Yeah, I can hear you.
Yeah, I can hear you.
Mhm.
I hear you fine. It looks like Wayne's gone. I don't know why.
Oh, I got him on my screen here. Oh, his mic isn't working. Okay, I think. Charlie. Okay, well, Wayne figures that one out. Charlie, you got a question, comment?
Just the in the graph in the upper left corner, I can't see any of the scale on that. Can you tell me what the scale is on the left-hand side? You know, the one that's got the funky the curve.
Can you still see it?
I can see it, yeah, upper left hand, but I can't read the numbers. They're like 3 pixels big on my screen.
Here, let's see if how's that?
Howard, maybe maximize the window.
It's getting better, and then
How's that?
There it is.
Okay. So yeah, so it's quite a large bounce there from -8 down to about -55 or so. Okay, yeah, that's huge. The phase shift I would expect with that effectively a series tuned circuit in the middle of the filter, I would expect it to go through with frequency, go through a funky phase shift there, but the numbers are pretty darn big, so it's not just a noise kind of thing. Okay, thank you.
Hey, can you zoom in on the circuit just below that so we can see the entire circuit?
No, the other circuit,
Oh, right.
the upper
No,
right.
no, that one.
No, it's the upper.
Which circuit generated that curve?
The upper right.
One beside it. This one.
Okay. Can you just zoom in and just show us that circuit? Okay. I just want to study it for a second. I think other people's got their hands up. Don't
Okay, well,
pause and wait for me.
Hassan, you got a question?
Yeah, one thing I was going to mention, I think seconding Dave's comment about Spice being unreliable, it might be good to check the connectivity of your net list, because sometimes it'll draw connections where there aren't any. So one way to do it is to kind of maybe look at the text representation of the circuit and see that it's connected the way you think it is, or I don't know, move the components around and see if the lines kind of disconnect or anything, or just
Well,
find some.
Yeah, Hassan, Hassan. That's why I wanted to look the circuit, because I wanted to see if there was a potential point where it was missing a connection. That's exactly what I was trying to look for in the diagram.
Okay, another thing you can do is you can actually do a pole zero plot and look at the pattern of the poles and zeros. One of them should stand out as being like on a Butterworth, they should all be like a circle. And so if any one pole is out of whack, you'll see it on that.
I'm not familiar with what you're talking about there with LT Spice, Hassan. What's that?
You have pole zero plot?
Yeah.
I
That's
don't
an
know I don't know if LT Spice has it. I assume it does, but it's what you like. You use this along with Bodhi plots, pole zero plots, or
Okay.
S-plane plot. Like that's what you do when you use MATLAB and stuff. But I assume that LT Spice has a way to do it. Let me see if there is.
You get your microphone back yet, Wayne?
Well, LT Spice doesn't have pole zero plots, but every other Spice does.
Oh, okay. Okay, well, I don't think I'm going to learn another Spice program just to get a pole plot, but anyway. Okay. Is there any other comments or questions for Howard? Any other comments or questions, period?
Well, thanks for your help. Everything's certainly a learning experience.
Yeah, it sure is.
Try some smaller
Yeah.
caps
Howard,
and do
Howard, I
a
would-
scan.
Hi,
Howard,
video's not there anyway. Sound isn't either. Who's on the phone?
Stephanie, they're working on David's thing. I got the thing from Paul.
Oh, you did, eh?
Turns out,
Howard, I would verify your LT Spice simulation, like what Hassan was saying. Like as I said, try a transient plot and just pick a couple of frequencies and look at it and look at the relative amplitudes and just compare that the amplitude, like at that peak, verify that at that peak you are getting a really big peak in amplitude. If you're not getting a big peak in amplitude, something's wrong, right? It's your simulation
Yeah.
is like wonky, right? And like as Hassan said, the connections. Double check your values. Make sure your values are correct. Reconnect, redraw it. I tend not to connect to the joins of where the part is. Like I notice you're connecting everything to where it joins. I don't think it matters. I'm just ADD. I just connect everything to like wire. I have wire connecting to wire. I don't really connect it to the node of the component, right? I don't think it matters. It probably doesn't matter. It's just me. I'm superstitious.
No, it does matter because
So
it's possible that you've got a connection, but you're not, like, for example, you've got your cap connected to a wire, but it's not connected to the inductor. So you're totally bypassing a section of the circuit. So that's very possible. So yeah, make sure you got like 3-point connections in the middle of a wire, like 3 wires connecting to each other, and then the wire should connect to the circuit component. So you'll see dots everywhere anytime you have a junction, and then you can just visually verify that it is. But the other way to do it is click on a component and move it around, and the wire should drag with it. If it doesn't, then it's unconnected.
Okay, I didn't know that.
Now, what's interesting was that today and yesterday, I was playing with this circuit on LT Spice. And in the end, I could not get this one to work. It was working, and all of a sudden, I just could not get it to work again. So I ended up basically modifying it into another circuit, which it turns out to be identical. But for whatever reason, one of them works and the other one doesn't. And I've yet to be able to find what the difference is. They're all the same, but one works, one doesn't. So maybe, as you were saying, double check the connections. Maybe there is something missing in mine that I have not noticed. So I'll have to take a look at that. But yeah, that's good advice. Any other comments, questions?
And also make sure it's the same component you're using. Because if you go in on your capacitor and you look at the type of capacitor, make sure they're all the same type.
Mhm.
You're not using like I don't know. They've got all different types of capacitors. You can go and select. If you go in to select component, you right click or left click on the component. There's a list of things it's got, and it's got parameters for inductors and capacitors. Just make sure they're all the same. Because if you've got one capacitor, which is I don't know, some other type of capacitor. Obviously, it's not electrolytic, but if, for example, it was electrolytic, it could cause problems.
Well, one capacitor
Right.
could have a higher ESR than another. Who knows, right?
Right, and so, but that's what I'm saying. You have to go in and just make sure that all the capacitors are the same. And typically, what I do, I don't select a new capacitor from the top. I just do a Control-C, Control-V. I just copy and paste the components. They're not Control-C. There's a little thing in the top where you can copy and paste, and that way I've got all the same components.
Okay. Very good. Well, that gives you a lot of work to do now, Howard. Expect an answer by Friday.
Okay, well, I used to work for the government, so you know what that means.
Okay, Monday. All right. Okay. Any other comments? Great. Okay. Thank you for bringing that up, Howard. Appreciate it. Okay. Well, let's go into our little round table then. And I guess I'll start off. Been carrying on with nothing but the Active Pro. It was well. Let me first thank Dave OI and Charlie as well for the help that you guys have been giving me on this project. It's actually gone from something after my first board. I thought this was going to be relatively easy, and I'm now up to version 4A. Version 4 is what I was referring to a minute ago about in LT Spice. I couldn't get it to work anymore, so I went to a 4A, and it works great. But anyway, I've done a couple of boards, and now rethinking the whole design in a way, and so I'm in the process of trying to be happy with what LT Spice is telling me, and then maybe within a week I'll get ready to do another board and see what happens. If I only wanted to do what my original goal was, which is just to see a very small signal, I could do that with version 1 board. And then, of course, things start thinking, well, let's improve the bandwidth, let's improve this, and then here we go with this rabbit hole. Anyway, supposedly it's a lot of fun. That's it for me. Howard, you're up next on my screen.
Well,
if anything?
Haven't really done much. It's just started building a transceiver again, and then we got sidetracked with the filter. So that's pretty well it for me. So
okay, well, if you need, I know you don't have. If you need a value of a cap, just let me know. I don't think I have the exact one you need, but I think I got on either side of it closer than the one you have. So if you need it, just let me know.
all right, I was just thinking that after all that kind of got lost in the shuffle. So I'll need that capacitor after all.
Yeah, what value was it?
The 130.
130. Okay.
I'll double check.
All right, and a 1206.
Yep.
Okay. All right, thank you, Howard. Al, what's new in your shack?
Okay, unmuted there. Well, Christmas has been in the way. I think probably we're all in the same boat. Anyhow, last week or weekend, I started going through some of my half-baked projects that I've never finished, and made some good progress on. There was a QRP watt meter SWR meter in Sprat magazine from G8 GYW. So we had a lot of good progress on this. It fits in an Altoids tin and a digital display, and we've got the board already done with a Stockton bridge on it.
Mm.
So I'm hoping to do the final checks this week and load the program up, and hopefully no smoke. I do have to admit the gods were angry with me last week.
Oh,
I tell you, after all these years, this weekend I did not know how to solder. I started by trying to reflow the components on, and we came out of the oven, and every little component swam away like a rubber duck in a pond. Uh, so the air was a little blue around here last weekend.
Oh.
Finally got it there. The original author used all surface mount components of the 0805 size.
Mhm.
I think that's about the smallest you can get. I think he has a sense of humor. As I tell you, these things go disappearing. If you try to hold them on and you shake your hand, they go flying across the room like you're playing tiddlywinks. So anyhow, I think we succeeded. So we're in the final throes of putting that one together. So that's pretty much it. One further comment, I guess, consider we're talking spectrum analyzers. I know a lot of you fellows have the modern Sigilent spectrum analyzers. I'm using an old Advantest boat anchor. Unfortunately, I don't have a tracking generator. So one of these days, I'm probably going to make the splurge and buy a new one. I'm just wondering what the consensus is amongst existing SA owners, and what model we might recommend en masse for the group. We don't have to answer that today, but maybe over the next month on the email, maybe we can chat about that. Be kind of interested in getting the recommendation from the group. Love my old boat anchor, but it's got to weigh 50 pounds, and without a spectrum, without a tracking generator, I'm kind of limited only looking at spectrums. I can't do filters or anything like that. So I'm having to use my Nano VNA for that.
The tracking generator, I think, is a must on it. Of course, the thing you might have to do, Al, is define your budget, because that's going to clarify what you can look for, whether you're going to go for like a Sigilent or you're going to go for the tiny SA. But,
well, maybe I have to define my retirement date.
There you go.
Work an extra couple months.
Well,
Retirement big gift.
I would recommend the 3021 spectrum analyzer, what I've seen, and there's been good reviews. This IMSAI guy did good reviews, and there's others around too. So I would recommend that one.
Yeah, there's a lot of us around here. There's there's another one. There's mine, and I think two others at least in Kingston are using them. So in our group, we got a few of them around. They seem to be pretty good.
Is this all the 3021?
Yeah,
Okay.
but you're also talking $1,300 US thereabouts.
Yeah, no, I think I'm aware of the price. I don't like it. What are you gonna do?
That's right. Well, you also have to be careful.
Yeah.
But I don't know about maybe things have changed now. I haven't looked at it for a while, but there was a while there where only Sigilent was offering the tracking generator included in the price, where others were asking for extra money. So anyway, okay.
Okay, that's all I got. So back to you, Peter.
Okay, Al, thank you. Charlie, you're up next. Good evening.
Good evening. Yeah, what I've been doing is, well, Christmas got in the way of things, of course, but for the last few days, I've been attempting to clean up a number of projects that have been hanging around the bench for some time. So I finished off the All-Star node for the Kingston Club, and got that up and running. I built a second one for myself to be able to test things with, and I'm looking at possibly turning up one for the for the Pembroke Club. So that's the radio portion of what I've been up to. Outside of that, I've been doing a little bit of paper and analog design, and also helping some folks with some networking issues. So no real breaking out the soldering iron just yet, but at least cleaning up a bunch of things that have been rolling around on the bench for a month or two.
Making room for more stuff to go on your bench.
That's right.
Hey, thank you. Dave, how you doing tonight? You still muted, Dave? There you go.
Yeah, I had to find a mute button. Not much. Christmas in the way, working away on my my continued investigation into the rabbit hole of MOSFETs. So I've been I actually built some experimental boards, making some measurements, and I took a break. And it just so happens I'm playing around with Chevy Chev filters. So that's why I know about type 1, type 2. I'm actually making a digital lock-in amplifier in Python, so to detect weak signals. So I've been playing around with that and playing around with filters. So that's about it.
Okay, it's interesting. You mentioned your rabbit hole with MOSFETs, and of course that's the our good old friend now. It seems like a good old friend now. The Miller effect. And while I was messing around, well, still am messing around with the active probe circuits, it wasn't long before I started, when I was doing my readings, it starts talking about, guess what? The Miller effect. Anyway, and I thought, I know a guy who knows about that. Okay, thanks, Dave.
Yeah, Peter,
Yeah.
Just let me just show you this. This is a board I made, and if you look over here,
Pull back.
See that spot? Okay, that's a driver, a TTL driver. It's a hex driver, high-speed driver.
Okay.
And that's taken a square wave from here, and I've connected all the gates together to increase the current. And when I do that, I'm increasing the current that's driving this MOSFET here. Okay, when I do that, out of that board, I'm getting 1 watt right across the HF band. So I've kicked Miller in the bagpipes because I'm just hitting that transistor, that MOSFET transistor with a whole lot of current, and that Miller plateau thing is just going over. And it worked. I'm getting, I said, 1 watt right across the entire HF spectrum.
Interesting. That's a lot, 1 watt. Eric, you're up.
Good evening, gentlemen. So I just want to comment, Al, on your 0805 quest there. It's child's play compared to what was being done at the SuperCon a couple months ago for the SMD soldering challenge, doing down to the 0201 by hand, which, if I'm not mistaken, are measured 10 by 20 mil, I believe, the components. Something like that. So anyway, talk about tiddlywinks. I think a late breeze would probably blow some of those away. Anyway, but I must say I didn't actually get to do the challenge myself, but it was interesting watching the people doing it. So what's on my bench? Well, it's still, again, I'll have the same excuse with holidays and everything else. This discrete component, well, it doesn't focus very well, but the GGG discrete kit that I'm working on. Oh, sorry, 555. I think I'm going to have to watch these videos that Peter has latched me on to. The IMSI guy has dropped a couple of them already, so thank you very much for that find, Peter. I appreciate that. He's doing the same kit as well, so I don't have anything other than the resistors on at the moment, but Like you can see, I got a nice clean desk behind me, so maybe I will have some space to actually do a little bit of holding the soldering iron from the right side of it. So anyway, that's about it from my end. So.
Yeah, just to clarify a little bit, the IMSI guy on the YouTube there has just coincidentally with Eric doing his 555 timer project, he got a bare board. He didn't want to pay the money for the kit, so he just bought the bare board off of them for $10, and he had all the parts on hand himself anyway, so he's built it. But he's doing an in-depth 4-part series on how the 555 timer works. So he posted part 2 this morning. He posts pretty much a video every morning. So take a look at it. It's quite interesting. And like I say, he posted part 2 this morning. I think today's is about a 20-minute video, and the day before was probably half that.
Yeah, I only watched the first few seconds. Is he doing the surface mount or the through? No, he's doing the through hole.
He's doing through hole.
Yeah,
Doing through hole. And today he's talked about the 2 comparator circuits.
Right.
And tomorrow I'll be talking about the flip-flop. Anyway, very interesting stuff. So he's got some good stuff on there. So if you're looking to have kill some time while you're having your morning coffee, check out the IMSI guys.
Yeah, absolutely. Thanks.
Okay, thanks, Eric. Frank, good evening. You're still muted there, Frank. And you're still muted. Yep. There we go.
Okay. I'm clicking things there, but the wrong things. My bench is completely covered and overflowing with QRP kits and processes. It's all my brother's stuff, but I've made it twice as bad because what I've done is I've decided to do what he did. It's time to unload all of the kits and stuff that I built the last 40 years. So that piled another piece of junk on the pile of junk. So when it goes up for sale, the whole thing goes up. And I have to bring them upstairs. Excuse me, I've got a frog there, won't go away. I have to bring them upstairs here, supposedly one at a time, but I see I've accumulated 10 different kits here to be tested because the power supply is here, the antenna is here, but it's too messy to assemble all of this stuff. This is the type of work. I'll give you a couple examples. It goes anywhere from here. This is a 15-meter QRP transceiver. And where, oh. And then built in the same case, all of these are pretty well built in similar cases, is this one's a filter and a keyer. Let me see now.
Okay, yeah.
Different vintage. But the design was such that they both go together.
Nice.
You're an artist, Frank.
Now, there they go. I'm looking at the monitor and everything's backwards. I did come across a variety of different rigs. a lot of receiver only, single band, a bunch of transceivers, all single band. And it came, I remembered that Dave wanted dibs on a transceiver. I don't know which one to pick out for him. So maybe you can comment, Dave, whether it's single band or multi-band. The multi-band ones are not QRP. It's like the FT101E that Eric got. Most of them are single band. Most of them are CW. There's a couple of single sidebands in there. The Neophyte used to be a popular design. I've got one of those. So anyway, you can maybe comment, Dave.
Yeah, Frank, you're gonna have to refresh my memory. Sorry, I drank too much over the holidays, and I can't remember what these transceivers were.
Well, I didn't list the transceivers. I just that time mentioned all the kits I had, and you popped up and you said you want the first dibs on a transceiver. Well, I've got maybe a half a dozen of them.
These are your kits? Because are they your kits you're getting rid of?
Yes, all my stuff and all my brother's stuff.
Oh, okay. Oh, I remember. Yeah, because I think you said it was your brother's stuff. You had gotten your brother's stuff, and you were looking to pass it along, right? Onto someone. Do you have a list of what you've got by any chance?
I'm working on a list, but now that I've added my stuff, the list is twice as long. So altogether, we're looking at 50 or 60 different.
Wow, that's a lot.
And in each one, I have to find the manual for it, test it out, and so it's going to take a while to get it all done. But in addition to that, I've got two big totes full of books, and if and when I sell at a flea market, I think I'm going to have to book at least 3 tables.
Oh. Yeah, if you've got the Wes Hayward, Not Experimental Methods, his other book. I can't remember. Yeah, solid state design. If you've got that, I'll take that.
I'm keeping that one.
Oh. Okay, I see. Yeah, Frank, I just had a thought. Can you maybe pick out the 3 best kits you've got? Because I would love to take them down to Dayton and show them.
Yeah, good idea.
I would really like, because Frank, you do phenomenal work. And if you could take your 3 best kits, 3 best rigs that you built, I don't care if it's CW, single, multi-band, doesn't matter. Just if you would allow us to just borrow them.
No problem. No problem at all, Dave. That would be good.
Any chance of you coming down to Dayton with us, Frank?
Unfortunately, I'm going to turn 88 next month, so I'm not really up to it.
I'll pick out the best bed for you. Sorry for your luck, Peter. On the floor.
What I've been doing so far is pretty messy around here with all this, but we're getting it organized, making a list, and packing them in bins. So they'll be all organized in 2 or 3 months.
Look forward to the list, Frank. Maybe we'll have to have one weekend at Eric's farm.
Frank, just hang on one sec. Sandy, are you okay with 60 more radios?
Oh, boy.
Hey Frank, I just had a thought. I've been meaning to come out and see you and have a coffee. Remember the old days? We used to hang around and have a coffee. you know what? And maybe sometime January, February, you know, I don't have much to do. I wouldn't mind coming out, paying you a visit, having a coffee, spending some time with you. Maybe you could show me some of the stuff you've got.
Yeah, I can do that.
Do it on a Saturday.
We have to unpack it.
Okay. No, I just thought that would be,
You're always welcome there, Dave. You're always welcome.
it would also give me an excuse to come out and see you, Frank.
Okay. Fair
I'll
enough.
just make one comment for Frank. Frank, I'm absolutely shocked because I heard you classify your stuff as junk, whereas when I used to come and visit you in your shack, you used to proudly show off in the corner your trophy case. You went from trophy case to junk. That's now I know in the ham world, junk is a good thing, but
yes, junk is a good thing. When it's all packed away in a tote or whatever, then it's classified as junk. When it's being displayed on a display case, then it's a trophy.
Very good.
Same thing, same kit.
Okay, I like that. Okay, thanks, Frank.
Okay.
Hassan, you're next on the list. Are you doing anything in the shack? Building, designing?
The last month was taken up looking for another car, so I had cars on the mind. I did get my lathe, my metal lathe. Something Al said was interesting, that he's talking about his boat anchor. In the machining world of old machines, the big heavy machines are the best. Lightweight is not. Whereas in RF, it's the reverse. The smaller the transistors get, the more ideal they become. So it's always good to get the latest and greatest hardware, because it actually performs much better in a smaller package. So that's what's been on my mind.
Well, you're right in one way. I had an HP spectrum analyzer, and I got tired of waiting for one of the boys to show up to help me take it off the bench, and I put it off the bench and I pulled my back out.
Mm-hmm.
When I picked it up, it took 2 of us to carry it out of this guy's basement to put it in my car. So the signaling I can hold with one finger.
That's right. And so the funny thing is, the only advantage kind of old radio equipment has is it's more immune to electronic jamming. So if you're worried about electronic warfare, the old stuff is good to keep around. But in general, I think smaller transistors have lower stray capacitances, so they're much more ideal. Like that extra cap you threw in the circuit and it caused a change in the characteristics. Imagine you stick your finger on the circuit. You're adding a few picofarads of capacitance there.
Yeah.
And so you could really mess it up that way as well. So.
Al has a comment there for you.
Just kind of comment on the boat anchors. About 2012, Mississauga got flooded, and I had 6 feet of water in my basement, my shack. And the only equipment that survived was that spectrum analyzer and the H3 scope, because everything inside of them was sprayed with conformal coating. It was basically waterproof. It dried off. I hosed it off, cleaned it up, and powered it back on, and it never looked back. So some of the old stuff is pretty good.
Yes, you hosed it off.
Yeah, I did.
That's funny. Should have taken a video of that. How to clean your electronics, because you remember Kevin took us through his painstakingly cleaning up those computer boards, and you just took a hose. Okay, thanks, Hassan. Let's see who's next. My screen keeps bouncing around here for some reason. Ken, what's on your bench?
Good evening and happy New Year's, everybody. Nothing much. I did get together with Dave and we sent out for version 2 of the DCR. So I'm just waiting for that to arrive in the mail. And then
you sent out what? Sorry, Ken, you sent out what?
Version 2 of the DCR board.
Okay. Yep.
And then once that comes in, I've got all the stuff for it. I'll put it together and do a test, whatever. I know that we had possibly discussed, people if they build the kit, they can order their own QRP labs. But what I decided to do was to include two very simple bandpass filters. Each filter is going to be two caps and one coil, and it takes like 15 minutes to put together. Um, it works quite well. It's a little wide, but if you decide you want to use the QRP Labs filters, the spacing on the headers do fit the QRP Labs filters. So you can just take the simple filter out and just put yours in place of it. Um, so once I get the new board and I'll populate it and play around with it, I'll have to get back to you guys and let you know what's going on. Sorry for the delay on the DCR. There's just too much going on in my life right now, or our lives right now. The other thing is, I don't know if you remember, I bought one of those Chinese SI 4735 radios.
Oh yeah.
Yeah, I bought that what 2 summers ago. Last summer, um, I had replaced the encoder on it because it was crap. I installed a bigger lithium battery into it, and it works quite well. But I came across a new one, and let me just share my screen quickly here. Where's share? Share. Okay, see that, guys?
Yes.
Yeah, that's what I picked up. Almost the same price as one of those cheap Chinese ones. And this one is an ESP controller. The code is written quite well, and oops, I sort of played around with it. It does not. It has um, a plug-in for a Li-ion battery, which took me down another rabbit hole. Um, so what I did is I have a bunch of 18650 Li-ion batteries, and I bought myself a battery tester, and I spent about a week charging and discharging the batteries to check if any of them were good. And it turns out of nine, there was eight good ones. So I got a nice little supply of batteries. But anyways, this one does not include the case, so I have to come up with my own. Dave, this is the one I wanted you to 3D print the case for. Um, I don't know if I want to still go ahead with that or just make my own. But anyways, once I get the battery installed, I'm gonna start playing with it and see how well it works. And I think that's about it.
Okay, that's great. Thank you for that, Ken. It's a neat looking radio. Okay, screen keeps jogging around. Who haven't I see? Cherry, good evening.
Hey, good evening, everyone, and Happy New Year. So, what's going on my bench? Almost nothing, doing a lot of reading these days. I've been busy at work. Hopefully, I should start on something. But yeah, what I'm doing is I have a small library with a lot of ham-ready books. So, I'm going through that. Yeah, and I need to also get to my kits, which I have got from the last date and so on. So, honestly, I've not been able to actually work on anything yet, even though I want to get to it. So building up some strategies for actually spacing up some time for regular kit work. Yeah, but outside of that, yeah, mostly reading some of the antenna books which I got earlier. Uh, and not sure I heard whether there is a plan to go together to Dayton this year. So looking forward to the Dayton event, and also looking to the other Hamfest which are going to happen soon. That's all.
Okay, thanks, Cherry. Joe, good evening.
Good evening, guys. How's it going?
Great.
Awesome. Happy New Year, everyone. So what I've been working on, I know, actually, this is my first meeting with you guys. So glad
This
to
was
actually.
second.
What's that?
I think it was your second. You did join us about a year and a half or 3 years ago. I can't remember which.
I'm not sure. Okay.
Anyway,
Yeah.
whatever.
But after a bit of an absence, I decided I needed to have solder smoke fill the space again. So after seeing one of the meetings that you guys had posted, I was like, okay, I need to get back in with this group again. But there was also talk about it was Kevin's suggestion regarding Whisper, and I think it was that NASA thing that's coming up in April. So what I ended up doing was ordering the ultimate kit from QRP Labs, and that came in. So normally I'm a super busy guy, like wearing 2 and 3 hats and whatnot during the week. But with Christmas finally having a bit of a break, I already started on the kit, and some of you already had seen the messaging. So this is the whatchamacallit, the GPS unit that's part of the kit. So that's already up and running, and the USB connection to it. So I'm actually getting the NMEA strings to it. So that bit's working. And then Dave, you were asking about this. So you're correct. The synthesizer is soldered to the board. So it's soldered to this daughter board. And so this goes on to the main one afterwards. So this is where the SI, was it 5351 goes on? So this is the guy here. And so I got that populated. And then for this, I was off for from the 23rd on. So I managed to do quite a bit of time getting the relay board all done up and populated, and all the toroids all wound up. So that's been completed. And so now I'm on to the main board. So that's the 80 meter low pass filter, and I've got a few more components to populate onto here, and then I'll be able to interface the display, get the thing powered up, and just get everything integrated together. So I'm close in getting this kit up and going.
You've been busy.
I've been busy. Yeah. So,
yeah, we'll have to change your name, Joe. We'll call you Joe the Toroid Almeida.
Toroid Joe.
Oh, nice. Yes, that was quite the job, winding those toroids. I just decided to break up a little bit every day, just wind away, have the coffee, wind away, have another sip. Away I went. So yeah.
Very good, Joe. Kind of all those toroids kind of reminds me of our antenna tuner project we did many years ago.
Right.
Where we developed what I called my toroid therapy sessions.
Oh yeah.
Anyway.
Yeah.
Okay. Thanks, Joe. Appreciate it. That's a report.
Right. Thank you.
About 3 years in the making.
You know it.
Michael, last but not least.
Okay, yeah. We went to Montreal for Christmas and had to do a few other things, and had a nice Christmas here, a nice New Year's here, and right now I'm back into after I bought a new FTDX 101D, and I wanted to implement that, integrate that with FT8, which required downloading stuff from the ASU website, and that took me a couple hours to do what I'd done in 5 minutes a month before, because I couldn't remember, and eventually got it all figured out. Everything is working now, but I'm still working on the antenna switch that Daniel V3NI and I are working on. There's been a few ups and downs. It now looks like it works properly. I'm just wiring up the manual versus automatic switch. I'm just wiring it up to check it all out. And once I get the breadboard working properly, then we're going to actually integrate it into a couple boxes. We're going to build 2 and we bought two boxes, 8 by 6 by 2 inches, and in powder gray and powder coated gray, and a standard aluminum one to practice on, so we can practice using our green leaf punches and the like, and our nibbler tools to make holes. But looks like it's going to work. We're going to eliminate an automatic switch by a rotary switch to switch between antennas. We're going to use a software thing that's going to run in Arduino, and Daniel's worked at the software, so we're going to try that out. But really not much else. Donna did this spectrum analyzer presentation to the Mississauga Club, and now tonight, and got some more things to think about it, spectrum analyzers and the like. I will look at the network stuff and just see how that works, Peter. And Al, for what it's worth, the company that if you're gonna get a signal spectrum analyzer, the company to get it from is RCC Electronics in Toronto. They're up in, I think it's Vaughan, up to 400 somewhere.
That's Radio College Canada, isn't it?
Beg pardon?
That's Radio College.
Where?
Isn't that the old Radio College Canada, RCC?
Oh, that I don't know. The company's called RCCE, Radio. It could be. I don't know. Maybe it is.
Okay.
Anyway, they you can go there. Like you order the stuff and from them, and they have it ready. They'll deliver it and whatnot. I had a problem with my first spectrum analyzer that got fried, I think, because of RF from my linear amplifier, which I subsequently sold to get rid of the problem. But they just replaced it for nothing. You know, it has a 3-year warranty, and they just replaced it. And I know that Dave has had some experience too with replacing analyzers. But that's where I'd go to get mine. I got my my oscilloscope from them, and also the signal generator from them. So I've been very pleased with the service they've given me. So, but not much else going on. I'm working on this thing that's going to be done, and hopefully the breadboarding will be done maybe tomorrow. And if it works, then we're going to go on to actually put the thing in a box, which is going to require some thinking about how to do that. Anyway, that's really all I've got for now.
Okay.
So back to you, Peter.
Thanks very much for that from Michael. Okay, that's great. Well, that brings us to the end. I think Wayne is left. Yeah. Okay, that's it for tonight. Thanks everybody for attending. We have next meeting on the 17th, I think it is. Oh, I don't have this thing. I think it's on the 17th.
Yeah, 17th.
We have Dave with his part 3 of the Miller effect, or the wind-up of the Miller effect, I guess it is, Dave. And Kevin will have another a segment of his cool chips. So that's what we got so far for that meeting. So I guess with that, thanks everybody for coming out, and we'll see you in a couple of weeks. Oh, yeah, we'll see you in a couple of weeks.
Yeah.
Thank you.
Okay.
Thanks, Peter.
Good night,
Good
everybody.
night.
Thanks, everyone.
Good night.
Have a good one.
Me three all.
Hey, Eric.
Hello.
When you get a chance, want to send me a link to the video?
Sure.